Hey, this is FlyWire on the road. I'm Scott Perdue. I'm at the McFarland booth where Flight Resource is located with the MT Propeller. If you're interested in talking and looking at MTs, you need to come here and you need to talk to John Nielsen. He's the expert. So
we have a lot of experts in our team on here, so
yeah.
I'm just one of a fantastic team of people that can help out any way we can.
Yeah, I think they're staying at Holiday Inn Express. But anyway, I wanted to talk about the MT. I know we did it at Sun and Fun a little bit, but it wasn't. We had a little bit of problems with the video and the audio.
Some audio technical difficulties.
Yeah. So I'd like to do that again.
Right.
So I wanted first off to ask, how do they make this prop? I know that it's wood with composite, and then we have the leading edge is metal. So run us through that. How does that work?
The basic configuration, the way that we're going to build this prop right here, is we're going to start off with compressed beechwood, and this is regular beechwood that has been infused with an epoxy and then physically compressed to give it a much higher density and strength. The result is that we have a very strong, lightweight piece of wood that has no fatigue, no life limits. It can be drilled and tapped to receive the lag bolts that are going to hold it in place. It's an amazing material once it's done in here. Take a feel of that density of that one.
It's very light, and what I do know that they're doing a lot of amazing things with compressed wood these days.
That is correct.
You can actually get strength and modulus of elasticity.
That's exactly
much
right.
better than steel for some applications. So wood is an amazing product.
This product right here, once it's compressed like this, actually has a strength that is higher than the metal equivalent to that.
Yeah. So it's fantastic. And this is the base of the propeller.
This is the base, and what we're going to do is we're going to use that here within the blade ferrule area.
Yeah.
And as we get up into this area, we're going to transition it into a lighter weight wood, because we don't need to have quite that strength all the way on up here.
Because that would be weight
a lot
as
of weight,
well.
A lot of extra weight. We want to try and get rid of weight, and that's primarily the advantage of the composite propellers. It's the number one advantage and why people would even consider them as weight savings over a metal propeller. So as we are going to transition then from the high strength composite or this beechwood, we're going to then move into the spruce wood. And you see the transition area here where that finger joint is done. It's almost like a tapered finger joint that you're going to have in a wood matching scenario. And when all those are mated and they're compressed and treated under heat and pressure, this entire block is then carved on out.
So what you have is a big block of wood that's prepared, and then you carve the block to the shape you want.
This is correct. MT has approximately, I think it's 40 or 50 different blade designs. So once the basic blocks are done, we can just tell our CNC machine what blade we want, and it carves it out. Individual blades carved out as needed for the application.
That's pretty cool.
We can do custom work that way too.
Yeah. Yeah, just well, I want it to do this or that. Of course, you have to have a reason. You have to have testing done, etc. So that's pretty cool. So then, what do? You've got the block carved the way you want it.
We've got the shape on in here. Now the wood is, and as we're going to look at the grain structure in here, you're going to see that the core of the MT propeller blades is set up of multiple spars of the spruce wood, each one laid with the grain opposite the next. And then this whole block before it's carved is put under pressure and heat to cure. So we have this composite structure we start with, carving out to shape, and now we want to simply protect it from moisture, protect it from impact, and give it some additional stiffness. And that is done by adding several layers of carbon fiber with the grain set up to do the proper amount of tension that we want in various parts of the blade.
Okay.
That's it. It's a little more complex than what we just described, but
right.
Yeah,
but that's general idea.
General idea.
Yeah.
Yes, that's correct.
Okay.
And after that, then it's just a matter of getting the epoxy finish on there, the final coat of paint, and then we're going to put the nickel leading edge on.
Okay. That looks like a pretty complex process there.
Yes. That. Here's an example of one of those nickel leading edges. Yeah. Here's an example here of one of the nickel leading edges. This nickel leading edge is not stamped, it's not milled, it's actually electroformed. Electroformed, yeah. It was been told to me that it's almost like 3D printing of metal. And what it allows you to do is to have a very thick apex right here in the area that's going to need the most impact resistance.
That hasn't been bent.
Hasn't been bent. Yeah. Nope, this is formed that way. It's actually grown that way. And then on the ends, we are razor thin right here. So
yeah, I can see you have tape here so people don't cut themselves.
That's exactly right. Because this is like razor sharp right over in this area. And because of that transition, there's no bump here. As we affix it to the blade, we don't have to mill it. There's no transition area. It's absolutely perfectly smooth, very hard here. It's flexible. Okay, so when the blade flexes, this can flex with it. It has the end cap that goes over and protects the edge of the blade as well. And this is replaceable. If it were to get damaged, it is replaceable. Now, I think I have there's a video out there where I took this section of blade and I shot it with a .22 rifle. And the bullet hit right here, and there's a video of it that you can find on YouTube, and yeah. I'll send you the video. You can put it on there.
All right.
And the bullet ricocheted off that with no damage at all, a smudge of lead. So I was quite impressed with that. And I took another shot at it, and I intentionally then shot to hit the blade so that I could then show in a few other samples on there of how you, the owner, is able to make...
Could repair that in the field.
Exactly.
Okay, that's pretty cool. That's... So you shot it here, and then again over here.
And then again over there.
Yeah.
Talking a lot here this week here. We've seen a lot of people. I think our attendance at this year's Oshkosh is probably record-setting.
Oh, that's good. That's good news.
Fantastic. I think they parked me halfway to Chicago in the airplane. The newest series of blades, this is an example of an Expedition series blade. This is used like on Husky aircraft, Cessna 170, 172s. We can put this on 180, 182s. We've actually put this blade on a 185 and even a 206. That this is available in a 2-blade or a 3-blade version. So depending upon the horsepower that your engine is producing is what we will use to determine whether or not you want a 2 or a 3-blade series.
And the length is all the same on
all
those?
83 inches on this particular Expedition series. Yeah, okay. 83 inch in total diameter.
So how do you determine the way the pitch angle changes throughout the blade? So here, that is at the base of the blade, that would be the relative wind, but you can see that it changes throughout the entire length of the blade.
All the way yes, it certainly does. And then as it is in flight and under power, the beauty of wood, and it was designed into the structure, is that this is designed to be able to flex and reflex against. What we want to do is basically we want to keep this blade from stalling. That's the important part. And think of it as almost like if you've seen the slow motion action of an eagle picking up a wet rabbit, out of the water and powering up back into flight. You'll watch as the wingtips are spreading and flexing. And the MT Propeller design, in the way in which they design the wood and the layup of the carbon fiber, is designed to do the same thing, to allow that tip to flex and not stall in the high power takeoff areas. That's probably one of the reasons why it's been very, very popular in the STOL contests, the short takeoff and landing, is that when you put a lot of power to it, the blade doesn't react with a stall, it just makes power.
Yeah, that's very interesting. While you were saying that, I actually was thinking about like a T6 blade, a -12, 12D40,
yes.
Or a Skywagon seaplane prop is making a lot of noise, and everybody always says it's because its prop tip's going supersonic.
That's correct.
Or close, and okay, maybe, but maybe it's actually stalling at the tip, and that's one reason why we're getting such noise.
Airflow disturbance is one of the things that the reaction to that is it makes noise. So the more you're going to disturb the air, and as you're approaching the speed of sound, yes, you're also going to have quite a bit of noise.
Yeah.
And that's also the reason why this is exactly 82.7 inches in diameter. Because if you run the tip speed calculator, you'll find that 2,700 RPM, 82.5 inches results in a tip speed at standard conditions at 0.85 Mach. This particular blade design, and most all of MT's blade designs, are optimized to make the maximum amount of power up to that point at that 0.86 Mach. Beyond that, every blade experiences a direct fall off of thrust as you begin to get a pressure. So as we approach the speed of sound, we get a pressure wave that develops in front of the leading edge. And that is going to disturb that airflow and it's going to reduce the amount of thrust. So if you hear a propeller that's making a tremendous amount of noise on takeoff, they actually could be making more thrust if they just rolled back the RPM and kept the tips going from supersonic.
Yeah. Well, the transonic region is really going to be about 0.9 or so.
Yes.
0.92. So it's
and that
not
is the
actually,
proper term. You're getting it's pre-supersonic, so it's just below that. It's in that transonic.
Right. So, but that's fascinating.
Yep.
I find that very fascinating, very interesting. So, how do you do the blade base for a constant speed propeller?
All right. In the metal shop of MT Propeller, we make our hubs and we make the ferrules and various components that go into the hub as well. MT is all self-sufficient. They make all of the components themselves right there in-house with the wood shop that does the pre-construction of the blade blanks. The metal shop is doing the work on the blade ferrules, the hubs, and things like that. So the blade ferrules and the hubs start off as a single piece, a billet of aluminum that is then CNC milled to the specifications needed on each application. Our hubs are a one-piece hub. They're not a two-piece hub. The benefit to that is that there's no fretting.
Right.
Okay. And the fretting is going to eventually cause that product to have a lifespan. And with a single billet that's carved out, that there is no lifespan, no life limits on an MT propeller system.
That's fascinating. So, are you working on any new STCs, spreading to new airframes?
We would see that there might be some interest in the 172s that have been converted to the 360, but maybe they didn't have the accommodation yet for a constant speed propeller. With those thousands of aircraft that are out there, if they're looking for a little bit more performance, that it's something that we may have here shortly for those customers as well.
Well, that's good news for the 172 guys.
Absolutely.
Actually, my 172 had an 0360 in it, 180 horse.
With a fixed pitch propeller, right?
It did, yeah.
Yes, yeah. See, and we're going to find an option to allow those customers, like your airplane, to go into a constant speed propeller. It will probably be an electric constant speed, but it'll operate just like a hydraulic. You'll set the desired RPM. The propeller maintains that, no matter what you're doing with climb or descent.
Well, that sounds very interesting.
Yeah.
Very cool.
So we'll have fun working with that when that comes up.
Well, great. Well, thanks, John. Thanks for talking with me about the MT Prop and letting me film here. And I know it's been pretty crowded, but we were able to get it done. Thanks for watching, and we'll see you next time on FlyWire.
Thank you.